We're going to look at compound inequalities. Compound inequalities are just like compound sentences. So if you think about a compound sentence, right, it's one sentence connected with a second sentence with usually an and or an or a but, right? So compound inequalities are exactly the same. We're going to connect two sentences, right? So here's one inequality and here's another inequality. And we're going to connect it with an and. So we're going to look at both of them at the same time. Or we're going to connect the two with an or. Here's an example of an and problem. So we have two separate sentences, one that's 4x is greater than 12, and then we have x minus 6 is less than 12. So what we'll do is we'll approach each of these separately and just solve each sentence as its own identity. So when we solve the first one, we divide by 4, we get x is greater than 3. Solve the second one, we get x is less than 18. But we have to remember that our and drops down. So we have two conditions. We have to have numbers that are greater than 3, and we have to have numbers that are less than 18. So let's take a look at the number line. So what we can do is we can take a look at each one individually. So let's take a look at what x is greater than 3 is. So if we have 3 here, we can think about it as all the numbers that are larger than 3, not including 3, so we don't shade the 3 itself. And now let's take a look at x is less than 18. Again, we don't shade the 18, it's all the numbers less. We're now going to examine what the word and means, right? It has to both be true. So if we're looking for a number that is greater than 3 and it is also less than 18, we can think about each of these numbers, right? So the number 24 is a number that is greater than 3, but it's not less than 18, so it can't be one and the other. Similarly, negative 12 is a number that is less than 18, but it's not less than 18 and greater than 3 because it's not greater than 3. If we pick a number like 12, it is a number that's greater than 3 and it is also less than 18. So you can see graphically that we're looking at all the points that are double shaded. These are the answers that are one and the other. So to show that on the graph as our answer, we're going to circle the 3 and the 18, and then we're going to shade everything that works for both one and the other, which is everything in between the two. That's what the word and means. If we take a look at the exact same two sentences, right, so we get x is greater than 3, we get x is less than 18, and the only difference is we put an or in there, it changes the possible solutions. It doesn't change what x is greater than 3 looks like. And it doesn't change what x is less than 18 looks like. But what it does change is the result. We're looking for any number that works in one or works in the other. So 0, let's take 0 for instance. Is 0 greater than 3 or less than 18? Sure. Because it's less than 18, it fulfills it. So this is a solution. Is 24 a solution, right? Is 24 greater than 3 or less than 18? Sure, because it's greater than 24, because it's greater than 3. Is 12 a solution? Sure, it is also one or the other, right? It doesn't have to be exclusive to each other, but it does work. So in this particular case, the solution would be all numbers, because all the numbers work. So while we have two individual sentences, whether it ends up as an and or matters. Another possibility is that we have a compound inequality that has two inequality signs within the same inequation, right? Okay, so you have the two less than signs. So this looks a little strange, but the process of solving it is very similar to everything that we do. So we want to get x alone. So x is right there. We want to get a lone, so we have to get rid of the 7. So what do? We subtract the 7. So that's no different. Now the different part is that whatever you do to one side, you do to the other side. In this particular case, we do it to every side. So we're going to subtract it over on the left side. We're also going to subtract it on the right side. So the only difference here is that you're doing it more than once. So we have -1. We keep the sign because we didn't divide by a negative. Keep that sign because we didn't divide by a negative. And we have that x is greater than -1 but less than 5. So what does this look like on the number line? Okay, I like thinking of this as just a physical thing, right? So x is in between -1 and 5. So we're looking for all the numbers that are in between -1 and 5. Graphically, it is all the numbers in between -1 and 5. Another possibility for a compound inequality is an absolute value inequality. So here again, we're combining our skills. Because you've solved absolute value equations, you might have an instinct about how to approach this. So if this was an equation, we would do what? We would get rid of everything outside the absolute value marks. Well, there's nothing outside the absolute value marks, so we can just go to the second step, and we're going to go ahead and split it. So we're thinking about all the things inside that could be equal to 3, except it's not an equal sign. So we're going to keep it all the things that can make it greater than 3. Now, just like an equation, we're going to split it and we're going to do the -2. So we'll do x plus 2, and we'll do -3. The difference in this case is that when we do the negative, it's almost like you're multiplying by a negative. So we're going to flip the sign. So you have to remember, when you do the absolute value inequality, you have to keep the positive and keep it the same. And then when you make it the negative, you also have to flip it. We'll solve each of these separately. We get x is greater than 1. We'll solve this one. We get x is less than -5. We're now going to graph this. When we graph this, we're going to graph all the possible solutions just as it seems, right? So we have all the numbers that are greater than 1. What we're saying is every number larger than 1 is going to work. We also have all the numbers that are less than -5. They are also going to work. So in this case, we have a whole bunch of numbers that work above 1 and below -5. The numbers in between, something like 0, is not going to work. Okay, so we're at the practice problems. Give these a shot. Check them out. Be careful. Make sure you're thinking about whether it's and or and how that works. And then we'll go over the problems. So we'll take a look at the first one. So we have 4x plus 3 is less 4 plus x is less than 3. So we'll solve that individually, and we'll have x is less than -1. And then we're also going to look at -2x is less than -4. Don't forget, because we are dividing by the negative, this is going to flip this around the other way. Okay, number line. So first we'll take a look at the actual equations themselves individually. So x is less than -1 is over here, and x is greater than 2 is over here. And what we're going to ask is, what does the word or mean? So in this case, we're looking for all the solutions that work in one or the other, which includes all of these. So those are all of the solutions. So we're going to look at the second one now. 20 is greater than -2x is greater than 10. We're going to get x alone by dividing by -2. Whatever we do to one side, we're going to do to all the sides. Again, I know that sounds a little strange. And because we divide by a negative again, we're going to flip the signs. So now we're going to look at what this means. Number line again. And we're looking for all the numbers that are in between -10 and -5. So x is greater than -10. X is also less than -5. So in this case, we have the numbers that are in between those two numbers. Those are our solutions. Last but not least, we're going to look at the absolute value of x plus 4 is less than 6. So this is an absolute value, and we want to get rid of everything outside first. So we'll subtract the 4. So we have the absolute value of x is less than 2. So the start of this is very much the same. The next step is also very much the same as an equation. We're going to split. So we have x is less than 2. And now this is the part that's a little bit different. We're going to still do the negative, but when we do the negative, we also have to flip the sign the other way. Okay, number line next. In this case, we're going to look for all the numbers that are less than 2. We're also going to look for the numbers that are greater than -2. So this acts a little bit like an AND problem, where all the numbers that are in between it are the numbers that work. If you pick a number that's greater than 2, right? So something that's greater than 2 that doesn't fit into here, something like 3. When we try it, the absolute value of 3 plus 4 is less than 6. You can see that that doesn't work. And if we pick numbers that are less than -2, right? So also outside of that, something like -4, the absolute value of -4 plus 4 is also not less than 6. So with these problems, you have to be thinking about what the ands, the ors, the absolute value means, and maybe try some numbers to see whether or not they work.